Assalamu alaikum. Assalamu alaikum, Shavir.
Assalamu alaikum.
Wa alaikum salam. Hope you are doing well and everything is fine over there.
Yeah,
Are you ready for today's lecture?
yeah,
Okay, so is there any question regarding previous lectures?
nah,
Okay. Have you revised, go through those lectures?
yeah, a little bit.
Okay, perfect. So let's start our today's lecture. Our today's lecture is also a makeup lecture of lecture number 11, right?
Yeah,
So let's start our makeup lecture today, lecture number 11. Let me share my screen with you. My screen is sharing with you, right?
yeah,
Okay, so here's our lecture number 11, makeup lecture. We will discuss in today's lecture about waves basis. We will discuss all about waves. Have you ever listened this word? What is waves?
yeah.
Okay, so what is basically wave? Can you tell me a bit?
Energy.
Yes, wave is also an energy. But how waves forms? Do you know?
Uh, how does it form?
Yes, how waves
There's
form.
there's like
Okay.
longitude
Mhm.
longitudinal waves,
Yes,
and
there are
then
longitudinal waves, right? These are basically the types of waves. Longitudinal waves, and the other one is also called as transverse waves.
yeah,
Okay, so let's start our today's learning objectives. We will define what is wave and we will also describe the main properties of waves. Some of them are amplitude, wavelength, frequency, and time period. These are basically some of the main properties of wave we will discuss in today's topic. Then we will understand the difference between transverse and longitudinal waves. Transverse and longitudinal waves are basically the main two types of waves depends upon the medium. Then we will apply the main wave equation, which is known as V is equal to F lambda, whereas V is the speed and F is basically the frequency of a wave, and lambda is known as the wavelength of the wave. Then we will solve some practical example numerical problems regarding these topic waves. So let's start with the introduction of a wave. What is basically a wave? How you can define a wave? So you can simply define a wave like wave is basically a disturbance in a medium. Okay,
yeah,
it is basically a disturbance in a medium. If there is no disturbance in the medium, there is no wave. If you disturb some medium, definitely the wave would generate. And what is meant by medium? I'm saying medium. Basically, medium means number of particles they occurs. If there are number of particles, it means there is some medium. If there is no number of particles, there is no medium. So can you tell me what is the medium surrounding you and me right now?
mm,
Is there any medium surrounding us?
um,
Definitely yes. Which
yeah.
medium surrounding us?
Sound.
Sun is yes. The light is coming from the sun. Yes, this is also. But an important medium is air.
Ah,
Yes. Okay. And you know that air also consists of small number of particles. So if
yeah,
air consists of particles, so it means air is a medium, right?
yeah,
So yes, so air is a medium. If there is no air surroundings you, you are unable to listen to anyone, you are unable to hear something. All you will hear things. This is due to wave and the medium is which is the air. So what is basically a wave? I told you that wave is basically a disturbance in the medium. If there is some medium, definitely there are number of particles, and if you disturb the medium, definitely those number of particles now start vibrating, and if those number of particles are now start vibrating, it means they are now producing waves. This is the simple definition of a wave. And you can also say a wave is basically a form of energy, and it basically transfers energy as well as information from one location to another location. So you can also say wave can transport your energy from one location to another location, right?
Yeah.
So wave is a disturbance in a medium and it transfers energy from one location to another. Wave can also travel through solids, liquids, and gases, because you know that there are number of particles in solids as well as there are number of atoms and molecules in liquids as well, also in gases. So if there are of atoms in these solid, liquid, gases, so definitely your wave can also travel through solids, liquids, and gases. Some waves like light can even travel through empty space, vacuum. You know that light is the one of the most type of wave which can be traveled through vacuum as well. What is vacuum? Vacuum is a thing in which there is no number of particles. Am I right?
Yeah.
Yes. So the only thing is the light wave. Light is also a wave. Okay. The only thing is light which can travel through vacuum. Other things do not travel through vacuum. Like light, radiations, and you know that radiation. The main example is the light coming from sun. Yes, there is no vacuum, there is no medium. All the space is empty, vacuum, but the light from the sun reaches to the earth. This is why, because light do not require any medium to travel. They can also be traveled through vacuum as well. That's why. Now move on
Mm.
towards main types of waves. The two main types of waves are transverse waves and the longitudinal waves. So, what is transverse waves? Transverse wave is basically a type of wave in which your particles vibrate. Definitely, particles should have to vibrate, but your particles vibrate in which direction? The particles of the medium vibrate perpendicular to the direction of propagation. Keep this thing, remember that your particles now vibrate perpendicular to the direction of propagation. What is direction of propagation? Direction of propagation means the direction of wave in which your wave is traveling, right?
Yeah.
So if your wave is perpendicular to the direction of propagation, this type of wave is known as transverse wave. Examples are water waves, light waves, and radio waves. Every light in the universe are transverse waves. Keep remember, okay?
Yeah.
And light waves consist of two things. One is the electric field, and the other thing is the magnetic field. And what is the direction between magnetic and electric field in light wave? They are perpendicular to each other. Light, but I told you that electric wave and the magnetic wave are perpendicular to each other in the case of light. That's why light is a transverse wave, because in which the particles vibrate perpendicular to the direction of propagation. Okay.
Yeah.
Hmm. What are the features? It shows crust, higher point, and trough, lower point. Do you know what is meant by crust and trough?
Uh, the trough and the peak.
Yes, the peaks. But crust, the, which peak? The highest peak, the upper peak, or the lower peak?
The low one.
The crust. I think the crust is the highest peak, the upper peak.
The crest. Okay.
Yes.
Yeah.
And the trough,
The lowest.
yes, lower. Let me show you from this wave illustration. So this is a wave, right? This orange line you can see is defined as the direction of propagation. It means your wave is traveling in this direction. There is no arrowhead, but let's suppose our wave is traveling in this direction. And this black curve you can see is basically the illustration of a wave. This upper peak is known as crest, and this lower peak is known as trough. Okay?
Yeah.
Each wave consists of one crest and one trough. So when one crest and one trough completes, then one wave completes. So here you can see up to this one wave completes. Again, up to this, the second wave completes. Again, up to this, the third wave is complete. So can you tell me how many wave cycles are there in this figure? How many wave cycles are there in this figure?
Uh, 3.
Yes, you're right, three. How three? Because as I told you, one crust and one trough makes one complete cycle. So this is one complete cycle here. Again, up to here is the second complete cycle, and up to here is the third complete cycle. So this is basically the three waves you can say. So in transverse waves, you can easily see the crest and troughs. This is the main feature, how you can identify a transverse wave, right?
Yeah.
Okay, now move on towards the second type of wave, which is called as the longitudinal wave. The only difference is that in transverse wave, the particles vibrate perpendicular to the direction of propagation. But in the case of longitudinal waves, your particles now vibrate parallel to the direction of propagation. So this is the example of transverse wave. So you can see this is the direction of propagation, and your particle is vibrating perpendicularly. You can see if you make a 90-degree angle, so you can see this is 90 degree. And again, if you draw this, you can see 90 degree. Again, this is 90 degree. So your direction of propagation is this, and your wave is traveling in perpendicular direction. So this is so-called as transverse wave. But in the case of longitudinal wave, what you can see, this is the direction of propagation, this orange line, but your wave now travels not perpendicular but parallel to the direction of propagation. This motion is also called as side-by-side motion, longitudinal motion, and transverse motion is also known as to and fro motion. This is to and fro motion, right? Because your particle is vibrating in this, you
Yeah.
can see to, fro, 90-degree angle. But in this longitudinal wave, your particles vibrate back and forth, back and forth. Again, it will move back and forth, not up and down, not to and fro, but back and forth. So this type of motion is called as longitudinal waves motion, and this type of motion is known as transverse motion. In longitudinal, your direction of propagation is the wave's direction is parallel to the direction of propagation, and in the case of transverse waves, your particles vibrate perpendicular to the direction of propagation. So the example of longitudinal waves are sound waves. Okay,
Yeah.
because it is side by side, so where molecules are close to each other, then their compression occurs, and where the molecules are far away to each other, then where rarefaction occurs. Here you can see compression and rarefaction. In longitudinal waves, there are two further types. The one is the compression, and the second is the rarefaction. Compression, where your molecules you can see close to each other. And here you can see your molecules are somehow far away from each other. This medium is known as rarefaction, right?
Yeah.
Okay. So in longitudinal waves, compression and rarefaction occurs. But in the case of transverse wave, your crust and trough occurs. What are features which I told you that compression where is high pressure region? High pressure region means molecules are close to each other, and rarefaction means low pressure region means molecules are somehow far away from each other. What is the key point? That all waves transfer energy. What is the main function of wave? Is to transfer energy from one place to another, which we discussed in the definition of wave. But the particle of medium only oscillates about a fixed position. Particle only vibrates about their fixed position. Either it vibrates to and fro. If it vibrates to and fro, it means this is the example of transverse wave. And if the particle vibrates back and forth, it means this is the example of longitudinal wave. But the particle still remains and it will only oscillate about their fixed position. Okay.
Yeah.
Daily everyday examples are simple. Ripples on a pond carry energy outward when a stone is thrown. Whenever you throw a stone in a pond, you can see some ripples. Okay, so this
Okay.
is those ripples are example of are basically the examples of transverse waves. Why transverse waves? Because you can see ripples becomes and ripples are example of transverse because you can see a pattern of crest trough. And another example is sound from a speaker travels through air to reach our ears. And sound, we know that sound wave is an example of longitudinal or transverse.
Uh, Longitudinal.
Yes, sound wave is basically longitudinal waves, right? And the last is the light coming from sun travels across space to Earth. So can you tell me light is the which type of wave, longitudinal or transverse? Either they need medium to travel or not.
Yeah.
Uh, first of all,
Transverse.
tell me light is which type of wave, longitudinal or transverse?
Transverse.
Yes, transverse. So, light need medium to travel, or they can also travel through vacuum.
Can travel through vacuum.
Yes, light can also travel through vacuum, right? If they travel through vacuum, so it means they do not require medium. They can also travel in vacuum as well. Okay, so here you can see the illustration between longitudinal and transverse waves. Is there any question regarding this?
Nah.
Okay, now move on towards the wave properties. There are some important properties of wave. The first one is called as the amplitude, which is denoted by capital A. What is meant by amplitude? Amplitude is basically the maximum displacement of a particle from the rest position. What is the rest position of a wave? On the direction of propagation line, so this is the direction of propagation line, right? Which I mentioned you before also. This line on which your wave is propagating, either back and forth or to and fro. Can you tell me this is an example of transverse wave or longitudinal wave? This figure.
Transverse.
Yes, transverse, because you can see the wave is propagating to and fro, 90-degree to the direction of propagation, and this is the direction of propagation. And on every point on the direction of propagation is basically the mean position, or you can say the rest position. What is amplitude? Amplitude is the maximum displacement from the rest position. So here is a wave. This is one complete cycle. This is second complete cycle, and this is the third complete cycle. Let's suppose we are taking this point, and this is the highest peak we got. So the distance between the rest position, main position, to the highest point the wave achieved, the highest crest, this is distance is known as basically the amplitude of a wave, right?
Yeah.
So the highest distance from the mean position to the maximum position is known as amplitude. Amplitude can either be in crest or you can also find amplitude in trough as well. How? If you can calculate the distance from this main position this maximum point. Either this is in negative, but this is also the amplitude. And amplitude is denoted by x naught. So this, if you consider this amplitude, you will say plus x naught, and if you consider this amplitude, so this is the minus x naught because this amplitude is in trough. Okay,
Yeah.
and this amplitude basically shows the energy. The greater the amplitude, the more the energy the wave has. So you can see the larger amplitude means more energy. So by just identifying the amplitude of a wave, you can easily identify how much powerful your wave energy is. If you are getting more amplitude, it means your wave has more energy. The second parameter is the wavelength, which is denoted by this symbol, and this symbol is called as lambda, Lambda, lambda. Okay, and what is this lambda is? Wavelength. You can define wavelength as the distance between two consecutive crusts or compressions is called wavelength, and wavelength is measured in meters. So the distance between two consecutive crusts or two consecutive compressions. So how many crusts are in this figure?
Uh, 3,
Yes, and how many trough are there?
4, 3.
Yes,
No,
three. How many trough?
3.
Yes, three. You can see this. One, this is two, and this is three. Three trough. One, two, three crust. So wavelength is the distance between two consecutive crust. So this is your one crust and this is your second crust. So the distance from here to here is known as wavelength, right?
Yeah.
And this is because this is distance, so you know that distance is made in meters, so definitely wavelength is also made in meters. So the unit of wavelength is meters, also the unit of amplitude is meters. And if I say the distance between this trough to this trough, is this is also called as wavelength or not?
Yeah.
Yes. So the distance between two consecutive curves as well as trough is also known as wavelength. Okay, and
Yeah.
if so, the distance from this to this is called one lambda. Okay, lambda is the abbreviation of wavelength, one lambda. And if I consider distance from this crust to this crust, can you tell me now what should be the value of lambda? Either one lambda or two lambda?
Uh, 2.
Yes, two lambda, because from here to here, you can see from here to here is one lambda. Again, from up to here, it's now two lambda. So, any
Yeah.
question?
Nah.
Okay. Now, the third parameter is called as the frequency, which is denoted by this small f. What is what is the frequency? How you can define frequency? Basically, frequency is the number of complete waves passing through a point per second. It means how many number of waves produces in how much interval of time in 1 seconds. And the unit of frequency is hertz, which is denoted by Hz. H hertz. Okay. If 10 number of wave cycles complete in 1 second, so you can say the frequency of a wave is 10. If 20 cycles of a wave completes in 1 second, then you can say the frequency of a wave is 20 seconds, 20 hertz, right? So how many wave cycles complete in a second is called as frequency. Okay.
Yeah.
Any question? Okay. So let's suppose from here, from this position to this position, the time interval is 1 second. So can you
Mm-hmm.
tell me what is the frequency now? How many wave cycle completes from here to here?
Uh, 1,
From this position to this position, first of all, let me know how many wave cycles completed. How many wave
3.
cycles are there? Yes, three. You are good,
Mm,
three. And if from this to this, the total time this wave took, let's suppose 1 second. And as I mentioned you before, if in 1 second, how many total number of wave passes is known as frequency. So now can you tell me what is the frequency of this wave? 1 hertz,
uh,
2 hertz, or 3 hertz?
3.
Yes, 3 hertz. Perfect. And let's suppose if from this position to this position, from this position, from this position to this position is the 1 second. Now can you tell
Mm,
me what is the frequency now?
2.
Yes, 2. Why 2? Because in 1 second, only two wave cycles completed. So how many wave cycles completed in 1 second? This is known as the frequency. Okay.
Yeah.
Okay. Now move on towards the next parameter, which is called as period. And this is also called as time period. What is time period? Time period is basically the time taken for one complete wave cycle. The time taken to complete one complete wave cycle. Now one, what you have to calculate how many time it takes to complete one wave cycle. One wave cycle completes here. How much time it takes? This is known as the time period. Let's suppose the whole wave completes in 3 seconds. So definitely the one wave complete in 1 second, the other wave cycle completes in 1 second, the other wave cycle is complete in 1 second. So if this wave completes in 3 seconds and if there are three number of wave cycles, can you tell me what is the time period? Either 1 second, two
Uh,
second, or 3 second.
3 second.
Yes.
Yeah.
How much time takes to complete one wave cycle is called as time period. The complete wave completes, let's suppose, in 3 seconds. Now, can you tell me what is the time period?
Uh,
Either 1 second, 2 second, or 3 second.
2.
I think one, because there are three number of cycles are in total, and there are 3 seconds. So each wave must be complete in definitely 1 second. 1 second for this, again 1 second for this, again 1 second for this.
Okay.
Am I right?
Yeah.
So what is the time period now? It means the single wave completes in 1 second, so the time period is 1 second. Okay.
Mm, yeah.
And if you want to calculate the total time period means for the total complete waves, there are three in total, and each contains 1 second. So these all three contains 3 seconds. So the total time period is 3 seconds, but for a single wave, the time period is 1 second. All right.
Yeah.
Any question regarding this?
No.
Okay, the last parameter is called as the wave speed. How you can calculate the wave speed? So you can calculate the wave speed by simply this formula, which is known as the wave equation, which is v equals to f lambda, whereas v is the wave speed and f is the frequency and lambda is the wavelength of a wave. Okay.
Yeah.
Now move on towards work examples. Here you can see example number one. A wave has wavelength 2 meters and frequency 5 hertz. Find the speed. You have to find speed. It means they're asking you to find V, and you know what is the expression? V equals to F lambda.
Yeah.
Okay, and the value of frequency is 5 hertz and the value of wavelength is 2 meters. What you have to do is to simply multiply 5 multiplied by 2, you will get your answer, which is 10. And this is the velocity, this is the speed, and you know what is the unit for velocity? It's meters per second. So that's why
Yeah.
the answer is also in meters per second. So answer is 10 meters per second. Second example, the period of a wave is 0.002 seconds. Period. Period means what value is given. This is time period. And we know that time period is denoted by capital T. What you have to do, you have to find the frequency. Important thing is in here is you can see what is the formula for time period. Time period is the reciprocal of frequency. Time period is equal to 1 by f, or you can also say time period is the reciprocal of frequency. Okay,
Yeah.
so here the time period is given, which is 0.002 seconds. They are asking you to find frequency. If t equals to 1 by f, so definitely f is also equal to 1 by t, because t and f are reciprocal. They are opposite to each other. They are inversely proportional to each other. So if you have to find f, so it becomes now 1 by t. So 1 divided by 0.002, you will get your answer, which is 500 hertz.
All right.
Okay. Another example, a ripple tank produces wave with speed 0.3 meters per second. Now what's this given? Either this is V given, lambda given, or frequency given, 0.3 meters per second. From unit, you can identify.
Frequency. Speed.
Yes, speed, which is denoted by V. Okay, so this means this is the value of for V, and frequency is also given, which is 6 hertz. What you have to find the wavelength. Means you have to find lambda. You know what's the expression? V equals to F lambda. And if you want to find lambda, so lambda becomes equal to V by F, right?
Yeah.
So the value for V is 0.3 divided by 6, which is the value for frequency. You will get your answer, which is 0.05 meters. And you can also convert it into centimeters because you know 10 equals to 10 power minus 2. So you can also convert 0.05 into centimeters. So 0.05 meters equals to 5 centimeters. How you can convert? You just have to divide it by 10 raised to power 100, you can say. Okay?
Yeah.
You can multiply and divide this number by 10 raised to power minus 2 because you know that the value for centi is 10 raised to power 10 power minus 2. And when 10 raised to power minus 2 multiplies, it becomes centi. And when 10 raised to power minus 2 divides, so 0.05 divided by 10 raised to minus 2, the answer is 5. So this is how 0.05 meters becomes 5 centimeters. Okay.
All right.
The fourth problem is a water has a frequency is 8 hertz. Find its periods. Can you find the time period if the frequency is given?
What?
Can you find the time period if the frequency is given?
Yeah.
Yes, t
Yeah.
equals to 1 by f,
Mm-hmm.
and the value for f is 8. So 1 by 8, which is equal to 0.125. And what is the unit for time period? Seconds. The time is made in seconds. That's why the time period is also made in seconds.
All right.
If a student has wavelength of 0.85 meters, now this is the value for lambda because this is wavelength, right? And frequency is also
Yeah.
given, which is 400 hertz. Find speed. It means they're asking you to find V. How you can find, you know, V equals to F lambda. Just multiply your wavelength, which is 0.85 with 400, which is the frequency. You will get your answer, which is 340. And we know that the unit for velocity speed is in meters per second. That's why your answer is 340 meters per second. A radio wave travels at 3 multiplied 10 raised to the power 8 meters per second. So this is the value for,
Uh, speed.
yes, speed. Means this is the value for V, and also the wavelength is given. Wavelength is 100 meters. Means this is the value of lambda. So the value of V and lambda is given. What you have to find? You have to find frequency. You know what the relationship is? V equals to F lambda. And if you want to find frequency F, so F now becomes equal to V by lambda. The value of V is given, which is this 3 multiplied 10 raised to the power 8 divided by lambda, which is 100. So just divide, you will get your answer, which is just 3 multiplied 10 raised to the power 6 hertz. And you know what is 10 raised to the power 6? This is in
Uh,
prefixes. In prefixes, 10 raised to the power 6 is equals to mega.
mm, megahertz.
Yes, mega. Because hertz, so megahertz. Any question regarding these problems?
Nah,
Okay. So, quick quiz for you. Can you tell me what is the SI unit for frequency?
hertz.
Good. If a wave has a frequency of 10 hertz, what is its period?
Uh, 0.1 second.
Yes, 0.1 seconds. Good. If a wave has speed 20 meters per second and a wavelength of 4 meters, what is its frequency? How you can find the frequency if wave speed is 20 meter per second and the wavelength is 4 meters?
20 divided by 4.
Yes.
5
And what is the
hertz.
unit of frequency?
Hertz.
Yes. Can you tell me in a transverse wave, in which direction do the particle vibrate relative to the wave travel? Either perpendicular or parallel.
Parallel?
In transverse
No,
wave, particles vibrate
perpendicular.
perpendicular or parallel.
Perpendicular.
Perpendicular, yes, you're right. And in the case of longitudinal waves, particles direction is longitudinal or sorry, perpendicular or parallel?
Parallel.
Yes, parallel. Okay. If a radio wave has a frequency of 100 megahertz and the wavelength is, what is its wavelength? You have to find wavelength. And if the value of speed is given, which is 3 multiplied 10 raised to the power 8, can you find the value for lambda?
Yeah.
How you can find?
Just V divided by F,
Hmm.
which equals to 3 meters.
And what is the unit of wavelength?
Meters.
Oh, yes, meters. Okay, so these are some assessment questions for you. You can do practice at your home. Okay.
Yeah. Yeah.
Any question regarding today's lecture?
Nah.
Okay, so if no, so that's all for today's lecture. We will meet
Right.
next Saturday at the same time. All right.
Okay. Right.
Okay. Till then, take care and Allah Hafiz.
I love this. Right. Bye. Love this.
Allah Hafiz.